All right, before we solve these problems here, I just want to remember that our goal is always to end up with x equals something, right? And we've learned that we're going to manipulate the equation because we were allowed to do the same to both sides. So as long as I add or subtract the same value from both sides, or I multiply one side by something, I must multiply the other by the same. And I can also divide one side by a value, but I also have to do the same to the other side. And that's fairly intuitive, right? It makes sense that we need to do that. So let's go ahead and take that approach here. And I'm always going to work vertically. So I want to get x by itself. And if I can get 4x by itself first, that's going to help me out a lot because I know how to undo the multiplication. But first I need to get rid of adding 15, so I need to undo that. So if I subtract 15 from both sides, okay, that's going to get rid of the 15 here. So I have 4x plus 0, and I don't need to write the 0, but 4x equals 29 minus 15. Which is, we do a little mental math, is 24, right? All right, so now, how can I manipulate both sides? What can I do to both sides to undo this 4x? Well, that's multiplication. So the inverse of that would be if I divide both sides by 4. So I divide the left side by 4, that's going to give me x. That's what I did on purpose. And to balance, I have to do the same to the other side. So I end up with x is equal to 6. Let's go back and check that, okay? So we're just going to check that. So 4 times, I'm just going to replace the x with a bracket. And we're going to check that, okay? So if I substitute the answer I got, okay, so that'd be 4 times 6 is 24, and 24 plus 15, that checks out, that works. So really, you already know you got the answer, okay? So there's no like, I wonder if I got that right. That's not a problem. All right, here we've got, now this one could be done a couple different ways, and I think I'm going to show it the most conventional way, which is just to apply the distributive property. Not necessarily the most efficient way. So minus 10x, if I multiply there, and then this is going to be negative 5 times negative 6, that's a positive 30, equals 60, and then we go ahead and solve. I want to get x by itself, so if I subtract 30 here, that's going to get me closer to where I want to be. So I'm going to subtract 30 from both sides. So then I'm left with 10x, negative 10x, pardon me, equals, and that's going to be negative 24, right? Sorry, this is 60. So it's going to be negative, it's still going to be positive. Okay, positive 30. Positive 30. There we go. And now I want to undo multiplying by negative 10. So if I divide both sides by negative 10, that's going to get me to x, right? So if I divide both sides by negative 10, this will be negative 3. Okay? I want to show you a different method for that. Let me show you a different method. I'll write the same question down, and then we'll check our answers. But if we get the same answer twice, chances are we did it right. So this is the same question. Let me double check to make sure that I wrote it down correctly. That's probably my biggest chance. So we can see where distributive property is multiplying. And if I just want to, make this more simple, I can undo the multiplication there. So if I divide by negative 5, right away, I wouldn't have to do the distributive property. So I'm undoing the multiplication. So then all I have is 2x minus 6 is equal to, and this is going to be what? Negative 12, right? So I add 6 to both sides. 2x is equal to, well, that's going to be negative 6. And divide both sides by 2, x is equal to negative 3. So we got the same answer. I'll still double check that. So let's go ahead and we have negative 5 times 2. And here's where we're going to put our x. Minus 6 is equal to 60. Let's put our negative 3 in there. So this would be negative 6 minus 6, so that we get negative 12 here. Negative 5 times negative 12 is equal to, oops, I didn't copy that right, is equal to 60. So that checks out. Good. All right, let's move on. Number 7. Now this one looks a little tricky to start with. We know that the denominator in a fraction is division. So this is saying 10 minus 2y, that's the unknown, divided by 4. So I'm just going to undo the division by multiplying by 4. And we know we have to do that also to the other side. We did that by design because we know that multiplying will undo the division. So I have 10 minus 2y equals, this is a little bit of a big number here. So 4 times 30 would be 120. And then plus 4 times 3 would be another 12, so 132, right? Again, like before, I'm trying to isolate so I can subtract 10 from both sides. So negative 2y is equal to, I'm subtracting 10, right? 122. And I'm going to divide by negative 2 to both sides so that we end up with y equals. That's an even number, so that works out nicely. What is that? Negative 61. Let's check that. So if I check that, 10 minus 2y over 4 is equal to 33. Let's just check and substitute here. We said it was negative 61. So 10 and then negative 2 times, that's 12. So 10 plus 12, that's 22. Oops. Oops, sorry. I was right, I wrote that down, 12. So 22 divided by 4. Did I get that right? Oh, it's minus 61. Oops. Ooh. So that would be 122. Okay, there we go. So 132 divided by 4, is that 33? 132. Oh, we know it is because we already did the reverse of that before. Right, because when we multiplied 4 times 33 up here before, we know that it came out to 132. And this is 132 divided by 4, which comes opposite of that. So it works out. Oh, the last one. Lots of fractions here. Well, we know just from the last question that any denominator in a fraction is equivalent to division. So if I think of this in terms of getting rid of all of the division, you know, I can go ahead and multiply by 5 to get rid of division, but I have to do that everywhere. And I actually don't, that's not going to undo the division for something that's not a factor of 5. So I need to find a multiple that is a multiple of 5. 5 is 1, but it's not a multiple of 3. So we want to get multiples that are common to all the denominators. So if we look at the larger denominator here, we have 5. That's not quite big enough. So let's go to the next one, 10. 10 is also not a multiple of 3. So let's go to the next one, 15. I think we found it. So 15 is going to be the number that works well. So if I multiply 15, 15, everything has to be multiplied by 15. Then we have 15 divided by 5, that's 3. 3 times 3x is 9x. 15 divided by 3 is 5. So plus 5 times 2 is 10. 15 divided by 3 is 5. 5 times 1 is 5x. And then we just have plus 15. Okay? We've got x's on both sides of the equation. We don't want that. We want it, so we could subtract 5x from both sides here. And then we're on our right track here. So, let's add, let's see, I want to undo adding, so I could subtract 10 to both sides. That's going to get me 4x is equal, when I subtract, I'm going to get 5. So x is equal to 5 over 4.